Good evening, my dear friends and respected teacher Mohammad Abrayan. I am Sudipto Pal and I am delighted to lead this presentation on the fascinating topic of multiplication. We are a team of 5 dedicated members including Shiabub Mobin Siam, Yasin Arafat Tasin, Mohammad Saqib, Arban Ali and also myself Sudipto Pal. Together we have worked diligently to explore and explain the concepts and application of multiplication in an engaging and meaningful way. Thank you for being us today and we look forward to your participation and feedback. So let's start. First version of multiplication hardware. The first version of multiplication hardware as described in the book Computer Organization and Design. The hardware or software interface by Peterson and Hennessy is a simple yet effective design that uses a combination of registers and ALU, which means arithmetic logic unit, and a control unit to perform multiplication. Key components: multiplicand register holds the multiplicand, which is the number being multiplied. Multiplier register holds the multiplier, which is the number by which the multiplicand is multiplied. Product register holds the partial products during the multiplication process and ultimately the final product. ALU performs the addition of partial products. Control unit coordinates the entire multiplication process, including shifting registers, controlling the ALU, and deciding when to store the final product. Multiplication algorithm. Point 1. Initialization. Set the product register to 0. Load the multiplicand and multiplier into their respective registers. Point 2. Iteration. For each bit in the multiplier, starting from the least significant bit. If the current bit is 1, then we add the multiplicand to the product register. Shift the multiplicand register left by 1 bit. Shift the multiplier register left by right by 1 bit. And point 3. Final product. After all bits of the multiplier have been processed, the product register holds the final result of the multiplication. Visual representation. Multiplicand register 64 bits, ALU 64 bits, product register 64 bits, and the last one is multiplier register 32 bits. So that's the end of my topic, and I would like to call my friend Siam to describe his topic. Thank you.
Assalamu alaikum. Myself MD Shihabub Mobin Siam. My ID last 4 digit is 1043. Today I talking about advantage of multiplication. Advantage: simple and easy to understand. Can be implemented using basic logic gates. Efficient for smaller numbers. Limitation: slower for longer number as it required multiple iteration. Require more hardware resource for longer operands. Improvement: both algorithms. This algorithm can reduce the number of addition required, especially for number with many consecutive zeros and ones. Array multipliers: those use a matrix of AND gates and adder of perform multiplication in parallel, significantly improving performance for longer numbers. Refined version of multiplication hardware. While the basic multiplication hardware described in the previous response is a good starting point, modern processors employ more advanced technique to achieve faster and more efficient multiplication. Here are some refinements. Array multipliers, parallel processing. Array multipliers break down the multiplication process into smaller parallel operations. Reduce latency. By performing multiple operations simultaneously, they significantly reduce the overall multiplication time. Scalability. They can be essential scaled to handle longer operations by increasing the size of the array. Both algorithm reduce operation. This algorithm reduces the number of additions required by grouping multiple bits of the multiplier. Efficient for spare numbers. It's particularly efficient for number with many consecutive 0 or 1s. Carry save adders, faster addition. These adders reduce the critical path delay by delaying the carry propagation. Parallelism. They allow for parallel addition of multiple partial product, improving performance. Pipelining, overlapping stages. By breaking the multiplication process into stages and overlapping their execution, pipelining can significantly increase the throughput. Higher performance. This technique allows for multiple multiplications to be processed concurrently. Specialized hardware. Fixed point multipliers. Those are optimized for fixed point arithmetic, which is commonly used in digital signal processing and their application. Floating point multipliers. Those handle floating point numbers, which are essential for significant and engineering components. Modern process implementation. Modern process often combine those techniques to achieve high performance multiplication. For example, they might use an array multiplier with burst algorithm and carry save adders, along with pipelining to further optimize performance. Key consideration for modern hardware design. Power efficiency. Low power design techniques are crucial for mobile and embedded system. Area efficiency. Minimizing the hardware footprint is important for cheap area constraints. Error correction. Implementing error detection and correction mechanism is essential for reliable operation. Security. Protecting against hardware attack such as side channel attack is incredibly important. That's all of my. Thank you. Now I calling Arman Ali to continue the presentation.
Assalamualaikum everyone. My name is Mohammad Arman and my ID is 1660. Here we can see the first slide, that multiplication flowchart. Binary multiplication is a fundamental operation in digital systems. It involves two numbers, the multiplicand and the multiplier. Thus the number being multiplied is multiplicand and the other number is multiplied by. Let's look at the steps involved. In the first step, we start the multiplication process. Second step is input. Here the two binary numbers, the multiplicand and the multiplier, are read into register. Third one is initialize product. The product register is initialized to 0 to hold intermediate result. Fourth is check multiplier bit. The least significant bit or LSB of the multiplier is checked first. Fifth process is if LSB is 1. If the LSB of multiplier is 1, we add the multiplicand to the product. Sixth step is shift registers. Next we shift the multiplier 1 bit to the right and the multiplicand 1 bit to the left, preparing for the next iteration. And the 7 is this process continues until all bits of multiplier have been processed. Final output. Once the multiplier becomes 0, the product register holds the final result. We terminate the process. Here the process all are int. In this slide we can see that the first version of multiplication hardware 190. The first version of multiplication hardware is a simple sequential design that mimics the manual process of multiplying two binary numbers. It consists of following components. They are multiplicand register, multiplier register, product register, algorithm logic unit. Its short form is ALU, and the other one is control unit. In this slide, the multiplication algorithm in action. The algorithm implemented in hardware process as follows. Initialization. The product register is set to 0 and the multiplicand and the multiplier are loaded into their respective registers. Here second point is iteration for each multiplier bit. For every bit in multiplier, if the bit is 1, the multiplicand is added the product. The multiplicand is shifted left by 1 bit. The multiplier is shifted right by 1 bit. Final product. After all bits of multiplier have been processed, the product register holds the final result of the multiplication. Thank you for your attention. Now my next team member will continue the presentation.
Assalamu alaikum. My name is Sakib and my ID number is 1746. Today I will describe about visual representation. In visual representation, there are four types of representation. 1. Multiplicand register. 2. ALU. 3. Product register. 4. Multiplier register. Advantage: simple and easy to understand, can be implemented using basic logic gates, efficient for smaller numbers. Limitation: slower for large number as it requires multiple iteration, requires more hardware resources for larger operands. Improvements: Bose algorithm. This algorithm can reduce the number, especially for numbers with many consecutive zeros or ones. Multipliers: these use a matrix of gate and adders to perform multiplication in parallel, significant improvement performance for larger numbers. Refined version of multiplication hardware 186. While the basic multiplication hardware described in the previous response is a good starting point, some modern processors employ more advanced techniques to achieve faster and more efficient multiplication. There are some in refinements. Array multiplication. Parallel processing. Array multipliers break down the multiplication process into smaller parallel operations, reduce latency. By performing multiple operations simultaneously, they significantly reduce the overall multiplication time. Scalability: can be easily scaled to handle larger operands by increasing the size of the array. Bose algorithm. Reduce operations. The algorithm reduces the number of additions required by regrouping multiple bits of multiplier. Carry safe errors. Faster addition. These errors reduce the critical path delayed by delaying the carry propagation. Pipeline. Overlapping stages. By breaking the multiplication process into stages and overlapping their execution pipeline and significantly increase the throughput. Specialized hardware. Fixed into multipliers. These are optimized for fixed point arithmetic, which is commonly used in digital signal processing and other applications. Floating point multipliers. These handle floating point numbers, which are essential for significant and engineering components.
Assalamu alaikum. My name is Yasin Arfat Tahsin. My RIN last 4 digit 1704. My topic name is multiplication. Key consideration for modern hardware design. Power efficiency. Low power design techniques are crucial for mobile and embedded systems. Area efficiency. Minimizing the hardware footprint is important for chip area constraints. Error correction. Implementing error detection and correction mechanism is essential for reliable operation. Security. Protecting against hardware attacks such as side channel attacks is increasingly important. Multiplication process 192. Step-by-step explanation. Start. Begin the multiplication process. Second, input. Read the two numbers to be multiplicate, multiplicand and multiplier. 3. Initialize product. Set the product to 0. 4th, check multiplier bit. Check the least significant bit LSB of the multiplier. 5th, if LSB is 1, add the multiplicand to the product. 6th, shift right. Shift the multiplier 1 bit to the right. 7th, check the int. If the multiplier is 0, go to step 9. 8. Go to sleep 4. Repeat step 4 to 7. 9. Output. Display the final product. 10th. Int. Terminate the process. Thank you and Assalamu alaikum everyone.